Hello everyone. In this video, I'm going to give you an introduction to C++ 11 standard. What are the new features? Are they really useful? The first one is initializer list. In C++ 03, you can initialize an array like this. This is called initializer list. This is nice. However, if you have a vector, and the only way to initialize the vector is pushing every value into the vector, which is not convenient. So C++ 11 extends the support of initializer list to many other classes, so you can initialize a vector the same way you initialize an array. What this does is it calling initializer list constructor. Note that all the relevant STL container has been updated to accept initializer list, like map or list. Beyond that, you can define your own initializer list constructor for your own class. In this example, I have a class BoVector, and BoVector has an initializer list constructor defined over here. This constructor takes a parameter of initializer list type, and in the constructor I go through each item in the initializer list and push the item into my own private data member MVec. Having that, I can initialize a BoVector the same way I initialize an array. I can also initialize BoVector like this, which is effectively the same. Second item, uniform initialization. C++ 03 allows me to initialize an aggregate class or struct with curly brace enclosed list. This is called aggregate initialization. C++ 11 extended the scope of curly brace initialization to any classes. So as long as the dog has a constructor that takes an integer and a string, it can also be initialized with the same format of curly braces enclosed list. So the regular constructor initialization, the aggregate initialization, plus what we've covered in the first item, the initializer list initialization, they all take on the same format of curly brace enclosed list. That is why they are called uniform initialization. However, in the eyes of the compiler, the three kinds of initialization are not seen as equal. They have different priorities. The uniform initialization will take initializer list constructor as its first choice, and a regular constructor as a second choice, and aggregate initializer the last choice. So when a compiler sees a dog is initialized with curly brace 3, the first thing it would do is search the class dog for an initializer list constructor like this. If that is found, it will take 3 as a single item array and pass it over to the initializer list. If that is not found, it will search for a constructor that takes a single integer as a parameter. If this is not found either, it will try to take dog class as an aggregate class and call the aggregate initializer for the age. Third item, autotype. Say we have a vector. In C++ 03, this is what we typically do to traverse a vector. I don't know about you, but for me, it is always vexing to have to type a long type name like this. So I'm thrilled to see C++ 11 introduce autotype. With autotype, it can automatically infer the type for it from its R value, the right-hand side value, in this case vec.begin. This will save me a lot of typing, and the less typing I do, the less typo I will make. Some other examples: auto a equal to 6, a becomes an integer. Auto b equal to 9.6, b become a double. Auto c equal to a, because a is an integer, c become an integer too. A side effect of this is IDE becomes more important because you want to hover your mouse over a variable and see what type it is. Otherwise, you have to fumble around to find the type because all you see is auto. For each, again, here's how we traverse a vector in C++03. In C++11, I can do the same thing with a much simplified coding, like this. What this means is, for each item of V, assign it to I and do something with I. This kind of coding can work on any class of V that has begin and end function. And if you remember, I can change the int into auto. If I want to change the value of V, all I need to do is adding a reference sign in front of I. And in this case, I'm incrementing each member of V by 1. So I'm changing the value of V. Now pointer. In C++03, now pointer is represented with now, which is defined as integer 0. However, this could be a problem. Suppose I have a function foo with integer and another function foo with char pointer. When I call foo now, which function am I calling? The foo with integer or the foo with char pointer? C++11 introduced a new keyword, now pointer, which is dedicated to represent now pointer. So when I call foo now pointer, it is very clear I'm calling the foo with char pointer. Enum class. In C++03, enumerators are basically integers. Here I enum apple, green apple, red apple, enum orange, big orange, small orange, and I define apple A equal to green apple, orange O equal to big orange, and as a result I can compare apple to oranges. If A equal to O prints out green apple and big orange are the same, and this code will indeed print out big green apple and big orange are the same. C++11 introduced enum class, and as the apple and orange are not just enumerators, they are classes. So when I define apple A and orange O, I have to add the apple and orange scope operator in front of. If I want to compare A and O, it will give me a compile error because I haven't defined the equal operator for class apple and class orange. So as you've seen, the enum class and the now pointer has made C++ more strong typed and more safe to use. Static assert. We are all familiar with assertion. At any runtime of the program, we can assert a certain condition is true. In this example, I assert that my pointer is not now. C++11 provides a static assert which allows you to make the assertion during the compile time. In this example, I static assert that the size of integer is equal to 4, which means the following code will not work if the integer size is not 4. Delegating constructor. It is very common for the constructors to share the same code. So sometimes it is desirable to have this kind of code. I've defined a first constructor, and I defined a second constructor which reuse the code of the first constructor and then do something else. However, this code can only work in Java. It won't work in C++. At least not work as you expected. It typically will create 2 docs instead of 1. So in C++, we oftentimes end up having code like this. We define a init function, and the init function will be invoked at different constructors. The downside of this kind of implementation is, first of all, it's cumbersome. Comparing to this code, I have to define an additional function, and this additional function will be duplicated in each constructor. Secondly, the init function is a regular function. It could be invoked by any other functions, which means the init function needs to take care of the additional complexity of being invoked at a different life stage of the object, not just the construction stage of the object. C++11 provides a new way to share the code of the constructors. The first constructor can be called at the initialization list section of the second constructor. This allows the first constructor to be invoked before the second constructor starts. The limitation here is the first constructor cannot be invoked in the middle of the second constructor or in the end of the second constructor. C++11 also allows in-class data member initialization. So for example, if the dog has a data member age, I can initialize over here with 9. And as a result, age will be initialized at every constructor.